Let me just share my screen. Okay, so can you guys see my screen now? Hello? Can you guys see my screen or no?
Yes, sir.
Yes, sir.
All right, so give me.
Sure.
All right, so going back to our discussion a while ago, so this is where we've stopped. So in here we have to continue this letter right here. So 26 is now equal to 1a, 1b, 1c, 1d, 1e, and then 1f. 6, 70, 89, 30, oops, and then 31, 1b, 1c, 1d, 1e, 1f, 18, 19, this is correct one. All right. And then let's see, the next one right here is the continuation of this number right here. So 19 is, next to that one is 20, same with 32, 33 is 21, and so on and so forth. Okay, so that's how we list the equivalence of decimal to hexadecimal, or decimal to octal. Or you can also have this one, hexadecimal to octal. Okay, same with those. Anyway, so this one might be a little bit confusing to you guys, since this is maybe your first time learning about hexadecimal and octal. But don't you guys worry. So we'll have a lot of examples regarding with that one. So yeah, that's the equivalence from 0 to 15, and then in hexadecimal, so 0 to 9 is the same, but in here it's now A to F. All right. So I hope that one is clear. So in here, we can actually convert binary to decimal, octal to decimal, hexadecimal to decimal, or any base to decimal. Okay. All right. So let me just give you guys an idea. What is this n base right here? So as you guys may already know, let's start with base 1. So base 1 is just 0. Base 2, okay, is ranging from 0 to 1. Okay. Base 3 is ranging from 0 to 2. Base 4 is ranging from 0 to 3. And then base 5, so let me just copy this one. Just copy the entire. Okay, base 5 is 0 to 4. And base 6 is 0 to 5. And 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, up to base 16. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, up to base 16. Okay, that's the maximum. So in here, it's ranging from 0 to, you know, 0 to 5. This one is 0 to 6. So just always last one. Okay, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 0 to 15. So there you go. All right, let me just stretch this one so that you can see it from top to bottom. All right, so in here, we've only talked about binary, which is a base 2. Okay, so that's another terminology for this one. So base 2 is equal to binary, or binary is equal to base 2. The next one right here is base 8, which is octal. And next one right here is base 16, which is hexadecimal. Okay, so there's one more, which is a base 10, which is the one that we are calling decimal. Okay, so we only have 4 to be exact, binary, octal, decimal, and then hexadecimal. And then the rest are called n base. Okay, so why n base? Okay, because this n is representing its base itself. So this one is 15th base, 14th base, 13th base, 12th base, 11, 10, 8, 6, 5, 4, 3, 2, and then 1. Okay, so yeah, those are the n bases that we are calling. And then the others, they have their own names. So binary, octal, and then decimal, and then hexadecimal. All right, so I hope I was able to, you know, enlighten you regarding with this n base right here. So what is the base of that one? Okay, so it could be any base, okay, aside from those four bases right here. Okay, so here's how we convert any base to decimal. So for integer, or let's say for whole number, okay, so to decimal, I just add all the products of each digit multiplied to its base in increasing power starting from 0. And then for fractional, okay, into any base to decimal, so add all the products of each digit multiplied to its base in decreasing power, or decreasing starting from -1. So in here, for the whole number, it's increasing. For the decimal or fractional, okay, it's decreasing. So in here, it's starting from 0. So 0, 1, 2, 3, and above. But in here, it's starting from -1, so -1, -2, -3, and so on and so forth. Okay. So yeah, I know this one is quite confusing if you're just going to read it and then try to understand it. So let's have an example or the format of this one. Okay. So ABC is whole number, and then XYZ is fraction, okay, or a decimal. Okay. So for the whole number, okay, you will start with 0 and above. So starting from C, it's 0, 1, and then 2. And then for the fraction part, so starting from X, this one is -1, okay, -2, and then -3, and so on and so forth. If you have more numbers on that fraction part, okay. So we always start with this dot right here, or the decimal point. So from here, just separate the whole number into a fraction, or from to a fraction number. So here's the whole number, and then here's the fraction number. Okay. So whatever is the value of this one, just put it right here for ABC. The same with X, Y, Z, and then whatever is your base. Okay, right here. Let's see, base 8. Then put here 8. Okay, if you have base 5, then you put here 5. And then just do the math, okay, using your calculator, then you will get the answer that you are looking for. So that's how we convert any base into decimal. All right. Okay. So let's have an example for you to be able to understand this one a little bit more better. So we have this A, B, C, D, E, F right here. So it is asking us to convert this binary into decimal, binary to decimal, octal to decimal, octal to decimal, hexadecimal to decimal. Okay, so here are the solutions. So again, just list everything from top to bottom. So 1, 1, 0, 1, 0, 1. So 1, 1, 0, 1, 0, 1. So that's the very first step that you need to do. And then just put multiplication in everything. Okay, so multiply it to its base. So as you guys can see right here, we have base 2. So your multiplier is 2. So 2, 2, 2, 2, 2. And then starting from here, since we don't have fraction, but you always start with the rightmost side, okay, if it doesn't have a decimal. So in here, this one starts with 0, or raised to 0, raised to 1, raised to 2, 3, 4, and then 5. So that's the reason why we have these exponents right here. So 0, 1, 2, 3, 4, 5. And then just add everything, and then you will get this result. So from binary into decimal. So are you guys able to follow on
Yes,
how
sir.
did we get this 53 right here? Okay, very good. So just use your calculator, or if not, you can do this one manually. Like for example, this one right here is 32. This one right here is 16. This one right here is 0. Okay, and this one right here is 4, and still 0, and then this one right here is 1. So just take note that any number raised to 0 is equal to 1, no matter how big is the number. Okay. If it's raised to 0, then that's equal to 1. So 1 times 1 is 1. And then just add everything, and you will get this one. And one more thing that you guys need to remember or take note is you have to put the base. Okay. So this is an indicator that you have already converted this binary into decimal. Okay. So the base of decimal is 10. So you have to put here 10. But then again, another notes. So I'll just announce it as early as of now. So in your quiz, so you don't need to put the base anymore. Okay. Yes, Mr. Van Egg.
Wala, sir. Sorry.
All right. So maybe na-misclick niya lang. Anyway, so from here, going back to your quiz soon for the module 4, you don't need to put the base anymore. Okay, so it's fill in the blanks. So if it's asking to convert this binary to decimal, so just put your answer. No need for the unit, okay, or for the base. But if we are in a face-to-face, method or face-to-face class, then of course you have to put the base, right? Anyway, so were you guys able to understand letter A? Is there anyone who wasn't able to get this one? Please let me know. All right, so I guess none. So that's a good sign then, hopefully. All right, so let's now proceed to the second example. So this one now has a decimal or a fraction. So again, just list everything from top to bottom. So 1, 1, my bad. So this one is from not from top to bottom. So 1, 1, okay, which is not this one. So from left to right, and then left to right, and then left to right, and then going down. Okay. So 1, 1, which is this one, and then 0, 1 is this one, 0 and then 1. And then 1, 0 is this one, 1, 0, and then 1 is now this one, and then 1 right here is now again this one, and then 0 is this one, and then lastly is 1. Okay, so that's the arrangement of this one. Okay, so I have said many one, okay, or the word one for this example. Anyway, I hope you were not confused on how I explain this one. Okay, so again, starting from the decimal, so right here is 0 and above, and then right here is -1, and then decreasing, -2, and so on and so forth. So this is the part wherein you will start with the whole number, and then this is the part wherein you will start with the fraction part. So 0, 1, 2, 3, 4, 5, and then 6. Okay, so if you want to check if you have the correct uh, exponent, then just count starting from here. So 0, 1, 2, 3, 4, 5, 6, and then verify. So if they're the same, then you're good to go. And then for the fraction parts, of course, they only have three numbers. So -1, -2, and then -3, which is now this one, -1, -2, and then -3. And then again, your multiplier will be the base. Okay, so we have a base of 2 right here. So your multiplier is 2. And then just do the math and then you will get 109.625. Okay, so I'll give you guys 30 seconds to 1 minute to analyze or to verify whether our answer is correct or no. So I hope you have your calculator with you so you can do this one easily. Yeah, the base is always 10 because in here we are always, in this is example only, okay? We are converting any base to decimal, okay? But if you are not converting, let's say, binary to base 8 or to base 16 or hexadecimal, then that's another topic, okay? That's a different topic already. But in here, it's just that, the base is always 10 because that is the one that we are asked to convert those bases, okay? And this is the process on how we convert any base to decimal. All right, so any other concerns? Okay, so while waiting for a question, so were you guys able, or is there anyone who were able to check whether this one is correct or no? 109.625.
Sir, correct.
Okay, so thank you for your response, Mr. Pasito. So coming from him, I said that it's correct. Okay, so I hope you guys were able to follow on how did we get this result also. Anyway, going now to the next example, we have 4,536. So this one has a base of 8, and then it's asking us to convert this one into decimal. So the same process, just line this one from top to bottom. So 4, 5, 3, 6, and then multiply everything to its base, which is 8. And then starting from the rightmost side, okay, and yeah, so we could actually call this one LSB, okay, or the lowest significant bit, okay, up to the most significant bit, okay, starting from lowest to highest. But to make it easier to understand, the rightmost number, which is 6. So starting from here, 0, 1, 2, and then 3. Okay, so raise to 0, raise to 1, 2, and then 3. So just do the math, and then you will get 2,398. So please verify this one if we have the same result. Anyone who's checking whether this one is really correct or no?
Tama po, sir.
Correct, sir.
Tama, sir.
None? None of you? We're checking whether this one is correct or no. Letter C.
Tama, sir.
Correct
Tama,
po,
sir.
sir. Correct.
Okay, wait lang. May nangyaring masama sa speaker ko.
Ay, gentle mo. Oo nga, sorry. Kawan woman. Nadamo ko na kung sir. Gentle talaga.
Hello, hello.
Hello, sir.
Matalagat mo.
Miss Kayla, could you please
Sir,
try to
tama
speak?
po.
Wait lang pala.
Yes, sir.
Connect na naman to sa headphones ko. Ayan, there you go. Alright, so anyone?
Sir.
Ayan, okay. Kaya pala wala akong
Correct
naririnig.
po.
Kasi na-disconnect yung
Hindi ka pizza, digiti ka, buidik pa.
Ay, bago ka lang.
Okay, how about letter D? So again, the same process, just line this one up from top to bottom. So 1, 2, 7, 4. And then starting from the decimal, so 7 right here is 0 and above. And then 4 is -1. And then just do the math and then you will get this one. So would you guys please check if this one is correct or no? All right. Okay, so correct daw. Coming from
Correct po.
Miss Kyla and Miss Emily. Right. So thank you very much. So yeah, that's how we convert any base to decimal. Okay, just line that one from top to bottom. So the same with this one. So we have B65F. But then again, in decimal or in hexadecimal to be exact. Okay, letter B is equal to 11. So you have to put here 11, 6, 5, and then F is equal to 15. And then multiply this 1 to 16 or to its base. And then starting from here, 0 and above. So 0, 1, 2, and then 3. So just do the math and then you will get this result. Okay, the same with letter F. So just line this one up from top to bottom. So you have to convert the equivalent number or equivalent letter of this one into decimal. So A is 10, C is 12, and then E is 14, and then 8 is the same with 8. Okay, so starting from here, 0 and above, and then starting from here, -1 below. Okay, and then just do the math, and then you will get 172.90625 base 10. Okay, so are we clear so far on how to convert any base to decimal? So that's the first thing that we have learned. Oops. So the first topic is decimal, any base to decimal. Okay. All right. So any questions so far regarding with on how do we convert any base to decimal?
So far, sir, wala na po. Understandable.
Good then. All right. So if we have any base to decimal, of course we also have decimal to any base. Or you can reverse it. Okay. So here's the process on how. All right. So let's have more examples with n base. So here we have binary to decimal. We have octal to decimal, and then we have hexadecimal to decimal. But in here we have the other bases, which is base 3, base 5, base 9, base 13, and so on and so forth. Okay. So again, just line this one up from top to bottom. The same process starting from the decimal. We have 0 and above, and then -1. Just do the math, then you will get 5.666. The same with this one, 123.1. So just line this one up from top to bottom, 1231. And then starting from here is 0 and above, and then starting from here is -1 and below. and then just do the math, and then you will get 38.2. Okay, so I'm not discussing this one quite fast, since the same idea, you know, just a different base, just a different multiplier, and different exponents. Okay, but the process is the same. Okay, the same with this one. So just line this one up from top to bottom, and then multiply them to its bases, and then just be careful if it has a decimal point. Then you should know that this one is 0 and above, and then this one is -1 and below. The same with this one. All right, and just put everything to your calculator, and then you will get the same results. Okay, and then don't forget the base. All right, so that's how we convert uh, n base to decimal, okay, or any base decimal. Okay, so supposedly you will do this one as your sit break if we are in a face-to-face method, but since we are in ODL, so I will leave this one as your self learning activities. Okay, so I would like you guys to do this one 1 to 15 to your notes, to your scratch papers, and you can message me. Okay, so let's just say, sir, could you please check my self-study activity if I've got them all correctly? So yeah, that is one way for you to verify whether you've got the correct answer or no. Or if not, then you can search for YouTube links wherein, which is of course another tutorials and how to convert any base into a decimal. Okay. Well, anyway, so in here we have uh, decimal to any base. All right. So again, the opposite of what we have just discussed. There is now our notes. Okay, let me just close this one, close this one, and then going back here. So we also have decimal to any base, which is now this one. Okay. So here's the process, or uh, the step-by-step solution on how you convert decimal to any base. So repeatedly divide the given decimal number by the base where you want the decimal to be converted to until the quotient is 0. Step number 2, for each division operation, tally the remainder. And then step number 3, if the quotient is already 0, write all the tallied remainders by reading them in upward direction. So in here, everything is quite the opposite. So before, from any base to decimal, so you're using multiplication, but in here it's now division. Okay. So yeah, and then we have another process wherein we are calling the quotient is 0, wherein you will only stop once the quotient is already 0. Okay, you will stop dividing once the quotient is 0. And then we have to tally the remainder. And then once everything is done, okay, everything is already computed as it should be, then just read the remainder from, where is that one? From bottom to top, so upward direction. Okay, so for you to be able to appreciate this one, so let's have an example. So convert this decimal 13 to binary. So in here, instead of multiplication, so you have to divide. So 13 divided by 2. So where this divisor or the number 2 came from? So it came from this 1. So if it's asking you to convert that 1 to binary, then your divisor is 2. If it's asking you to convert this decimal into octal, then your divisor is 8. Okay? If it's asking you to convert this decimal into hexadecimal, then your divisor is 16. Okay? But in here, it's just a binary. So you just have to divide this 1 by 2. So 13 divided by 2, so just separate your answer. We have here the whole number or the integer part and then the remainder. Okay, so if you're going to get the exact result of this one, so of course you will get 6.5. But then again, you have to separate that one. So 6 for the whole number, and then the 0.5 or the remainder 1 will go in here. All right. So next, just copy whatever is the last integer quotient value, put it right here, and then 6 divided by 2 is 3, so remainder 0. So 3 divided by 2 is equal to 1, carry 1 or remainder 1. And then 1 divided by 2 is cannot be, so just put here 0, and then whatever is the last value, just put it as your remainder. Okay. Or you can actually get the exact answer, which is of course 0.5. So 0 for the integer, and then 0.5 times 1 is equal to 0.5, or that 0.5 will become your remainder, which is now equal to 1 when it comes to whole number. All right. Or just to make it not so complicated, once this one is not divisible anymore, okay, and then you're now getting a decimal result or answer, then just put here 0, and then whatever is the last number, just copy that one as your remainder. And then once that's over, then just read this one from bottom to top. Okay, so 1101. 1101, of course, should be base 2, since that is where it is asking you to convert that base, so from decimal to binary. Okay, so were you guys able to follow?
Yes, sir.
Okay, so I'll give you guys 30 seconds to 1 minute to understand, to analyze, to internalize, to, or whatever you're calling that one, on how you will try to understand this example. So please let me know if one of you were able to understand this one already, just by saying, yes, sir, we were able to get it. Or you can just type your feedback. Okay, so Miss Giovanni, we're already able to understand this one. So your result or your answer right here will be the remainder only. Okay, so integer quotient is just part of your solution, but your final answer will be coming from the remainder. All right, so since we don't have enough time anymore, so we will just continue the rest on the part 3. Okay, so goodbye for now, and see you guys later.